Hello, everybody. Excuse my voice. Hopefully that gets more normal sounding. All right, so here we are at the review for the final exam. All right, this has been a weird semester, and we are getting to the very end of it. All right, so I'm sure that you all are happy to be done with online coursework. You just have to finish some exams online and you'll be all done. In case you were watching this, shortly after I post it, don't forget that the paper is due on Sunday night. I have created a place on Blackboard for you to turn it in. There's also, I think I turned on the turn it in function so that you can see what proportion of your writing the software thinks is coming from some other source, so you can make sure that there's no plagiarism in your writing before you submit it. And then you can submit as many times as you want, and I'll just grade whatever the final submission was. So that is open now, and it will close at midnight on Sunday night for submissions. And then your final exam will be next week during exam week, according to the university schedule. All right, so our exam will be at noon on either Tuesday or Thursday, and you can get that information about which day you are from the syllabus. Even the original syllabus has the correct dates there. All right, so today we're going to talk about some things about the final exam, and then we're going to review some topics. Only one person sent in a question, so I'll make sure to cover his question, but otherwise I'll just review some things that will be relevant for the final exam. All right, so of course I managed to forget my piece of paper when I walked down here to Connor 111, but I'll try to remember what it said. On the final exam, there are going to be 60 questions. All right, so 60 questions, 56 of them are going to be either true, false, or a multiple choice format. All right, so 56 of them, you would have bubbled in on a Scantron. This is going to be split up to be, no, I'm like, I can't remember the numbers. 10 true, false questions, 30 multiple choice that we will call like a general knowledge kind of multiple choice. Just do you know the material that was covered in the chapters that concluded this semester? So all the stuff in the syllabus after the midterm can be covered on the exam. All right, so 10 true false, 30 multiple choice that are general knowledge sort of multiple choice questions, and 16 multiple choice that fall into this category that I will call pick the test. And this is like the data analysis plan. All right, so I will give you information about how some variables were measured on a survey, and it will ask you to to determine how those variables were measured. Are they categorical or continuous? And then I'll ask you some question that can be answered using the data from those variables, and it will ask you to determine what kind of analysis would need to be done to answer that question. All right, and so it's just like the data analysis plan, except the questions aren't going to have to do with ADHD medications. All right, so this, nope, see, here's where I've already messed up. Oh, yeah, okay, sorry. So this adds up to 56. All right, and these are each going to be worth 1.5 points each, which comes out to 84 points, all right, out of 100 points on the test. All right, so 84% of your test is going to come from this multiple choice and true false part of the test. And then at the end of the test, there are going to be 4 questions worth 4 points each. And that's going to be the final 16 points on your test. And this is going to be short answer, all right, that asks you to interpret the results of a data analysis. All right, so there will be 4 questions where I tell you, here is how the data was collected, here's the question that the researcher has, here is the answer that SPSS has spit out. Now tell me what that answer means. All right, and so basically here, you're going to be doing what you guys are working on now, interpreting all of those analyses that I posted to Blackboard, determining, do you reject or fail to reject the null hypothesis? What does it mean in plain English that you've done that? And as the short answer to this, you're just going to write the conclusion in plain English, just one sentence for each of these 4 analyses. The conclusion in plain English, that does not say plain. Plain English will be your answer to that question. All right, so that gets us up to 100 points. All right, 60 total questions worth 100 points. 84% of it is coming from multiple choice type questions. 16% of it is coming from these short answer type questions. The topics that will be covered, the short answer, let me make some more room on this desk. The short answer is that the final exam can cover any topic that happened after the midterm exam. All right, so go to your syllabus, find where spring break occurred. Anything that's written on the syllabus after spring break could be covered on the final exam. All right, so these topics are sampling, data coding and editing, descriptive statistics, inferential statistics, and I think they call the final chapter communicating the research results. All right, so this is what will be on the final exam. All right, and we'll go through some of these topics today. Some of them I'm not going to go through in such great detail, specifically sampling and the data coding and editing. Mostly today what I'm going to talk about is the statistics stuff, because this is, I think, where people get confused. When you're studying, watch the YouTube videos. I was thinking the one good thing about this online format is that if you did not understand something the first time, the video is there and you can just watch it again. So that's helpful. All right, so watch the YouTube videos, look at the PowerPoint slides, all right, hopefully while you're watching the YouTube videos. All right, look at any notes that you've taken, all right, read the textbook. The specific pages that should be read from the textbook are provided in the syllabus. All right, so look in the syllabus for the reading that would happen, for all of these topics. And this is what you should be studying, all right, to prepare for the final exam. Now, one thing that I will say about the final exam is that you may find some of the questions tricky. I mean, I assume that that's the case, especially for some people. These things are going to be kind of tricky, and this might be kind of tricky. That being said, I don't write any questions onto any exam ever just to try to, like weed out the best students, so that only 2 students got this question right and everybody else missed it. I want all of you guys to get 100% on the final exam, right? Every question that I have written into to be a possible question on the final exam is a question that I think, if you watch the videos, you should have learned this information, right? If you read the textbook, you should have learned this information, right? And so I am not asking any question just to make it hard to get an A on the test, right? Just to make sure that you learn something really obscure, right? Or anything like that. I focused on what do I think are the most important things that students from this class should have learned, should be able to take with them out into the world. And that's what, in my opinion, appears on the final exam. All right, it doesn't mean that the exam is easy. All right, I've heard rumors that the final exam in this class is really hard. I think it's just hard because it has math. All right, and a lot of people don't really love math, but it is what it is. All right, this is a class that has math, and so that math has to show up on the final exam. All right, but I want you to know, honestly, like from the bottom of my heart, I am not trying to make this hard for anyone, right? Especially in the situation that we're in right now. That being said, study for this exam, right? Study. I know that this is an interesting sort of format. I've never given an exam in a format where students have the book available to them and whatever notes they've taken available to them and, handouts available to them. So I don't know if that'll make things easier or harder. I know when I was in undergrad and I had open book exams in classes, sometimes I fell into the trap of not studying enough because I assumed that I would be able to look up the answers during the test. There's not enough time in the exam to look up 60 answers in a textbook. All right, so you need to study before the test. Don't lull yourself into a false sense of security that you're going to have all this material in front of you during the exam and you'll be able to reference all of it while you're taking the test, because while that's true, if you rely on that 100%, all right, looking up every single answer in the book as you go through the test, you're not going to get through the test before the time runs out. All right, so I should say that this is going to be 60 questions in 90 minutes. All right, so you'll have 90 minutes to take the test. And if you have SDS accommodations, I have to figure out how, because I've never done a test in Blackboard, but if you have accommodations to make your testing time longer, then that will be done on an individual basis. So your specific test will be available for longer in Blackboard. Okay, so I think, unfortunately, you guys are not here in Connor 111 with me to tell me if I'm missing something important, but I think that this is all of the basic information before we get into the actual, topics that are going to get covered. Remember, these are the topics down here. The specific pages that those topics are covered in the textbook are mentioned in the syllabus, so please go back to the syllabus to see exactly which pages you should be reading. Please watch the lecture videos. All right, going to YouTube, looking at the view numbers on these videos, I'm getting the impression that a lot of you have still not watched these lecture videos. I don't know what it's like for you at home right now. I have no idea. I wish I did. I wish I knew what it was like for all of you guys at home right now. I don't have any idea, but I do want to just say the number one thing that you can do to study for this test is just watch the lecture videos. All right, watch them on your cell phone. All right, if you don't have a nice desk set up in your room, wherever you're staying, watch them on your cell phone, watch them on a laptop, watch them somewhere. Please just watch the lecture videos, all right? Because that's reading the book is helpful, all right? But I don't think it's as helpful. Of course, I don't think it is because I'm the teacher, but I think the lecture videos are helpful. All right, so please watch those. All right, let's get into some specific topics. Normally what happens on the final exam review day is that I go over kind of like, now that you guys typically would have done all of these analyses in SPSS, but now that you guys have done the data analysis plan, you have gone through all of the analyses that I posted on Blackboard, and you are interpreting those results and writing the results into the final paper. Now that you have some hands-on experience, all right, with these statistics, I like to take a step backwards and go over again this idea of hypothesis testing, all right, and what everything means that's going on in there. This is going to show up on the test, all right? So this inferential hypothesis testing is a topic that can be on the test. All right, and so I want to make sure that everyone has a clear understanding of what's happening here. All right, so let's say there is something that we want to know. All right, and we're going to put it in this box over here. And this box is a reference to the fact that there is some thing that we're interested in knowing about the population. In this case, the thing that we're interested in knowing about the population is, let's just say something simple. Do men or women take ADHD prescriptions more often? All right, so there is this fact about the population. In order to learn this about the population, we would have to conduct a census. All right, so remember, a census means that we talk to every single man and woman in our population of interest. All right, so we would have to conduct a census by talking to every single man and woman, and we would have to measure with no error. All right, so all the men, we would have to ask the question in a really precise way that allowed people to give the honest truth about the question, and no one could lie, all right, or lie on accident because they misinterpreted the question, etc. So we would have to collect perfect data, perfectly accurate data from every single person in the population to get the answer to this question. All right, and if we did these things, all right, if we did conduct a census and we did conduct measurement without error, then we would just calculate the mean frequency that the men reported, the mean frequency that the women reported. We would ask ourselves, are those two numbers the same? And if they were not, then whichever number was higher, we would say that's the gender who takes this medication more often. All right, we wouldn't have to do anything beyond that because we would have perfect information from everyone in the population. So we would know exactly how often they were taking it and which groups was higher. The problem is that accomplishing these two things is basically impossible. All right, we never conduct a census. It takes too long, it's too time consuming. If we miss even one person in that population of interest, just one person fails to take our survey, then we no longer have a census, all right, we have a sample. Typically though, our samples are not just one person missing from the population, it's a deliberate step that we take where we say, I want to know this piece of information about the population, all right, whether men or women take ADHD medication more often, but I can't collect a census. So what I'm going to do is I'm going to take some subset of the population, all right? I'm gonna put this operator here to reflect the fact that the information over here is more than the information that we're getting over here, but I'm gonna get some data from a sample, all right? I'm going to draw, sorry, there's something bumpy on the table, so it draws funny. I'm going to randomly draw names from this population. Those people are going to be in my sample, and I'm going to ask each of those people in my sample, are you male or female? And how often do you take ADHD medication? All right, so I get this information from my sample. All right, I get some information. I'm going to have some mean response from the men, and I'm going to have some mean response from the women. All right, and this is this data that I collect from the sample. When we report the information that just our sample has given us, so just the subset of people whose names we drew from the population and we sent the survey to them, these are called descriptive statistics. All right, and descriptive statistics describe the sample. All right, that's all they do. They say absolutely nothing about the population. They are not, they should not be used as, to say, well, because we found this in the sample, this is what's true in the population. No, descriptive statistics describe the sample. We know that what we find in our sample is not perfectly true of the population because of this error. All right, when we draw a sample, we have sampling error. All right, stemming from the fact that we know that the people who were not chosen would have given us different answers. All right, so our sample is going to differ from the population simply because we only got a subset, and the missing people's answers would have changed the numbers that we found. All right, so we know we have sampling error. We also know that we have systematic error stemming from people deliberately lying. All right, maybe they think that there's a stigma about taking this, so they underreport how often they take it. Or maybe they just misunderstood the question, or they estimated how often they take it and their estimation wasn't exactly accurate. But we have some systematic error, all right? So people did not give exactly perfect answers, all right? And so because we have this error in our measurement, we know that the information that we have gotten over here is not exactly equal to this thing that we're interested in determining, all right? And so we're interested in determining this population parameter. All right, so what's in this box is called a population parameter. All right, this is the truth in the population. It's what we could assess, what we could determine if we conducted a census and measured without error. All right, but we can't do that. All right, and so instead what we're going to do is we're going to use this imperfect information that we have gathered to make an inference about that population parameter. All right, we're going to say, based on what I learned from my sample, here's my best guess about what's true over here in the population. All right, and so our inference of that parameter is we're going to say the parameter is equal to, all right, the answer that we found in our survey. All right, so our descriptive statistic, answer from survey, plus or minus some error. All right, so we take this information that we got from our survey, we know that it has error, so we're going to combine this information, what we found from our sample, plus or minus some error that we know exists due to the fact that we drew a sample, and we're going to use this information to estimate what's true at the population level. All right, and so that's why we have to take this additional step, all right, of either doing a confidence interval, all right, or doing t-tests or doing something else. We cannot look just at what our sample gave us and say, what the sample said is true for the population because this error exists. All right, and what the inferential statistics do is they account for that error. All right, they recognize that that error is there and they deal with that error when they make their estimation of what's true for the population parameter. All right, so we learned about, we focused our efforts this semester on hypothesis testing. All right, and so up here we have this question, do men or women take ADHD medications more often? All right, so what we're doing here is we're comparing the mean consumption for men and the mean consumption for women, and we want to know, remember, we want to know about the population. So what we want to know is is the mean consumption, mu is the population mean, is the mean consumption for men equal to the mean consumption for women? All right, are men and women taking this medication at the same rate? We don't actually have any, I mean, we do from our survey. I don't remember that data off the top of my head. All right, but let's say in a sample that we found different means. All right, so let's say that we ask how many days per week do you take ADHD medication? So they could answer 0 through 7. And let's say that in our sample, we find that the men's mean was 3 days a week and the women's mean was 2 days a week. All right, let's just say that we find these numbers in our sample. All right, so our sample data, the descriptive statistics that we got, this is just the data from our sample, suggests that there might actually be a difference between the men and the women. The problem is, all right, the reason why we can't just say, oh, look, our sample says the men are taking it more often, so that means men are taking it more often in the entire population. The reason why we can't do that is because there are two explanations, all right, for how, to explain this, all right? One explanation is that the result that we found in our sample is just due to error, all right? And so what this means is that at the population level, all right, this box up here that we are trying to estimate, at the population level, I don't think there really is a difference between men and women. I think I found this result in my sample due to chance and error. All right, let me put this in a way that people can see. All right, so our first possibility is that this answer that we're finding in our sample is just a fluke of the specific sample that we drew. And if we had drawn a different random sample of names, right, if a different group of students answered the survey, maybe we would have gotten completely different numbers. Maybe men and women would have had the exact same number. Maybe the women's mean would have been larger. And so what we're concluding is that this is potentially, this is not reflecting any true pattern that exists at the population level. Maybe this is just a fluke of my sample. It's a result that is isolated to just this one specific sample that I drew. It doesn't reflect anything about the population. It doesn't reflect anything about the potential answers I would see in other samples, right? It's just a fluke of this one specific sample that I drew. These specific 100 students gave me this answer, but I would not expect any other group of 100 students to provide this same answer, all right? I think that this is just error that caused this result to happen. The second possibility is that we found this result in the sample because at the population level, men really do use ADHD medication more frequently. All right, so maybe we found this result. Maybe we found this result where the men are saying 3 days a week and the women are saying 2 days a week. Maybe we're finding that because at the population level, had we conducted a census, we really would have found that the mean of men was larger than the mean of women. And because that's true at the population level, we're finding it in this sample. All right, so the second possibility is that this sample is a good representation of the population. And as a result, we are seeing population level trends show up in our sample. Importantly, this does not mean that at the population level, the men's mean was 3 and the women's mean was 2. It just means that the men's mean was larger than the women's mean. And so we are seeing that pattern show up here in our sample too. All right, so we have these two possibilities. We have one result, two possible explanations for how we found it. All right, either it's a fluke of our sample or it is not a fluke. All right, our sample is just accurately reflecting the true nature of the population. All right, that the men's mean really is larger than the women's mean. All right, and so what we need is a test to determine which one of these two things is more likely to be true. right? Is it more likely that we found this result due to error, or is it more likely that we found this result because it's an accurate reflection of the population? That's what these inferential statistics are doing for us. Every single one, right? So in a minute, I'm going to talk about the differences between the different kinds of t-tests and the differences between, the chi-square test and correlation and all of that. But at their very base root level, every single one of those tests is doing the exact same thing. I found some pattern, right, or evidence of some relationship in my sample, and I want to know now, do I think that this pattern is a fluke of my sample, or do I think that that pattern is reflecting something real about the population? And we have all of those different tests because we have different kinds of patterns. In this case, the pattern that we're looking at is a mean of one group versus a mean of a second group. All right, and so when we do this test, we would use an independent samples t-test. All right, and we did not get deep into the math of all of this, and I'm not going to today, but the reason why we do this test is because this test, the math that's underscoring what's happening here, is dealing with the fact that these are means, they have associated standard deviations, the error terms are being derived from two independent groups of subjects who provided these means, right? And so that's why we have this separate test. When you have a paired samples t-test, the assumptions are different. So you have a different test that you have to do to deal with finding out which of these is more likely to be true. All right, but every single test at its root is saying, I found some pattern in my data. Is that pattern a fluke of the sample, or is that pattern reflecting something real about the population? The test is going to tell you that answer, right? And we just have to do different tests for different patterns. When we do that test, we have two hypotheses, all right? The null hypothesis, the alternative hypothesis. For an independent samples t-test, the null hypothesis is that regardless of what your sample found, the men's mean is equal to the women's mean, right? And the way that this corresponds to this paragraph over here is that we're saying at the population level, I think men and women take this drug with equal frequencies. And my explanation for how we found this in the sample is that it was just error. All right, so there's not really a difference between men and women at the population, and any difference I found in my sample is just a fluke of this specific sample, right? It's the result of chance and error. The alternative is that we found this difference in our sample because there really is a difference at the population level, all right? And so maybe this was not a fluke of error. Maybe we found this pattern in the sample because the pattern really does exist in the population level. That is our alternative hypothesis. All right, so we do this independent samples t-test. Let me pull some more paper down here. We do this independent samples t-test, and what's happening in this independent samples t-test, and in all of the tests, is that we start, if you remember, we talked about this law and order metaphor about we start with the assumption that the defendant is not guilty, and there has to be sufficient evidence to prove his or her guilt beyond a reasonable doubt. So we start with this assumption that the null hypothesis is true. All right, that's always where we start when we do these tests. All right, and so we start with this assumption that the men and the women are taking these drugs the same amount. And the question is the difference that we found in our sample strong enough? Is it big enough to convince us that this must not be true? All right, because if this were true, it would be very unlikely to find these differences. All right, going back to the law and order thing. If, we're supposed to start with an assumption that the defendant is not guilty. And the question is, once the prosecutor comes in and says, well, the defendant was there with the gun and the defendant's DNA was at the scene and the defendant, their DNA was on the victim and all of these things, that starts to be some very strong evidence that leads you to doubt the plausibility of this, right? It makes you say, I don't know if that person's not guilty because there sure is a lot of stuff pointing to their guilt. All right, and so it's the same thing here. We start with this assumption that men and women are taking these drugs at an equal rate. And the question is the information that we got from our sample strong enough to convince us that this must not be true? All right, so we would do this independent samples t-test. The result of the t-test would come back as a t-statistic, and we would get the associated p-value. All right, the t-statistic is going to be some number, right, between negative infinity and positive infinity. And the larger the t-statistic is, the more difference there was between the two groups. All right, and this is going to be true of all the test statistics. All right, so the t-tests are measuring differences. All right, so was there a difference between the men and the women? If the t-statistic is really large, that means there was a big difference in the sample between the men and the women. As t approaches 0, that means that the men and women gave almost the same answer, right, in the sample. And then as t increases, p decreases. All right, and so the p-value is telling us, I'll write this out again in case it helps anybody. Manage all this paper. The p-value is the probability that sorry, I'm trying to look at the screen and write at the same time and it's not working. The probability that we would find a difference between men and women in our sample as large as what we found. All right, so this is horrible English, but what this is saying so far is, what are the odds that we would find a difference this large? All right, so whatever the difference between the two means that we found in our sample was, what are the odds that we would find a difference that large if there were no population level differences? All right, so if the null hypothesis is true, all right, if the null is true, there are no differences between men and women. At the population level, men and women are exactly equal to each other. What are the odds we'd get our sample result? All right, and so the logic here is, let's say that we get a p-value back of 0.70. This means there is a 70% chance that if this were true at the population level, that we would manage to draw a sample that showed this difference. All right, there's a 70% chance that that could happen just because of sampling error. All right, and those are pretty good odds. You know, like we'd say, oh, you know, that's a pretty decent chance that we could, you know, honestly find this result in the sample just as a result of sampling error and the chance of the odds of individuals being drawn into the sample if the null hypothesis were true. All right, those are pretty good odds that we'd find that. All right, and so we would fail to reject the null here. All right, we'd say, you know, there are pretty good odds that the null hypothesis is true despite this information that we found in our sample. But as the p-value gets smaller and smaller and smaller, all right, we start to get more and more suspect about whether or not the null hypothesis is actually true. All right, and so going back to our court metaphor, as the prosecutor brings more and more and more evidence and stronger evidence that suggests that the defendant really did commit the crime, the jury, presumably, is starting to get less and less convinced of that defendant's innocence. All right, and so as this p-value gets smaller and smaller, this means that there are smaller and smaller odds of finding this result in our sample, given that this is true. All right, so this assumption is that this is true. We draw a sample from the population where this is true. What are the odds that we could find results like this if this is in fact true? And as this difference in the sample gets larger and larger and larger, all right, like, you know, if we have the mean of men is 7 days a week and the mean of women is 0 days a week, we would end up with a really big t statistic, right? Remember, t increases as the difference between the groups increases. So here, this is as different as they possibly can be. So we would have a really big t statistic, and because our t statistic is really big, we would end up with a really small p-value, because that would say then there are very small odds that we would manage just by a fluke to draw a sample where all the men said 7 and all the women said 0, if in fact this is true. All right, that would be a very fluky sample. All right, we would have had to have, managed, even though there are lots of men who answered 1 through 6 and lots of women who answered 1 through 7, we managed to pull only the men who drew 7 and only the women who drew 0, that seems very unlikely. All right, and so this p-value would reflect that. There are very small odds of drawing a sample that looks like this from a population where this is true. And if those odds are really small, specifically, if the odds are less than 5%, then we're going to say this must not be true. All right, it is basically impossible. All right, there is less than a 5% chance that this could be true given these results that we found in our sample. All right, and so when those odds get really small, and the point at which we've defined the odds as being small is less than 0.05, then we are going to reject the null. All right, and that rejection of the null is saying, we started with this assumption that the null was true. I think that's a bad assumption. All right, the odds of finding this result in a population, from a population where this is true, are so small that this must not be true. All right, and so we reject the null and we conclude instead that I drew this sample from a population where men really are taking this drug more often than the women, because that's the only thing that makes sense. All right, statistically, probabilistically, it is so unlikely to have managed to draw this result from a population where this is true that I reject this. I say this must not be true. And instead, I'm going to side with this and say this is now more supported. All right, so the one thing that we have to point out here when we talked about those error rates, if the odds are less than 5%, so there's a less than 5% chance that the null could be true given this result that we found in our sample, less than 5% does not mean 0. All right, so that means there is still a chance that the null hypothesis is true. There is less than a 5% chance, but there's some chance, right? It's a very small chance, very slim odds, but it's possible that the null hypothesis is still true and that this result in our sample is just a fluke of the specific sample that we drew. And so our error rate is tied to this. So if we reject the null here, there is roughly a 5% chance that we were wrong. 5% chance of being wrong when rejecting the null. And honestly, this number fluctuates, with the p-value. So if p was equal to 0.001, that means that there is a 0.1% chance of being wrong when we reject that null. But our threshold, our tolerance of being wrong, is at 5%. So that's why we have this decision rule. If p is less than 0.05, we're going to reject the null. And if it's greater than 0.05, we're going to fail to reject the null. Because even if the odds are only 6%, all right, if the null hypothesis is true, if p is equal to 0.06, that means there is a 6% chance that the null hypothesis is true, given the magnitude of the difference that we found in our sample. But if we reject the null, there's a 6% chance that we're wrong when we do it, and we're only willing to be wrong up to 5% of the time. All right, so even if p is equal to 0.06, we're going to fail to reject the null because our odds of being wrong are too high. All right, so 0.05 is this magical point at which we say, okay, the odds of this null being true, given the differences that we found in our sample, are so small that I'm going to go out on a limb, I'm going to reject that null, and I'm willing to tolerate this 5% risk of being wrong when I do that. All right, and so that looking at the p-value, looking at the magnitude of the differences that we saw in our sample, this is how we get information from our sample and use it to draw an inference about the population. Right? It's not just guessing, right? It's a calculated guess. It's saying, what are the odds that I'm right when I do this? What are the odds that I'm wrong? And generally, we're pretty conservative because we're only willing to be wrong 5% of the time. And so if the data from the sample exceeds this threshold, at which point we say, all right, it's really unlikely that we would find a difference this large in our sample if there were not also a difference in the population, then we say, okay, that assumption of equality in the population must be wrong. I'm going to say that my sample is reflecting something true about the population, and you side with this alternative hypothesis, that says we found this result in the sample because it's reflecting something real about the population. This thing, what I've just described here, it's exactly the same for every kind of test that we learned. We just have different tests depending on the nature of the pattern that we're looking at in our data and how that data was collected. All right, and so there are hundreds of tests that we did not talk about in class. We talked about just a subset, right, that I have over here. Sorry, this is the only copy of this that I could find, and it has 2 tests circled, so we'll just have to ignore that. But the next thing that I want to do, because this is the thing that the student asked about, is I'm going to go through each of these tests that are in the table and talk about in what situation would you use each of these tests. All right, and so I have a pretend survey here. And let me make sure that the camera is up high enough that we can see all of the questions. Sorry. Okay, so imagine, let me stack these papers up. Imagine that we have this survey, all right? It has 1, 2, 3, 4, 5 questions. All right, how much do you enjoy grocery shopping at Kroger? 1 to 9 interval response scale, anchored, not at all, and very much. How much do you enjoy grocery shopping at Walmart? Again, 9-point interval response scale, anchored, not at all, and very much. How much do you spend per month on groceries? The ratio response scale, people write in a dollar amount. On which day are you most likely to do your shopping? A weekday or a weekend day? And what is your gender, male or female? All right, so let's imagine we have these questions on a survey, and now we want to answer some questions about shopping, right, based on the data that's in this survey. Right, and one thing, based on the emails that I'm getting from students, a thing that I guess is still confusing, despite having worked through the data analysis plan, is that there seems to be this feeling that, okay, we have this survey, so now we're going to look at the data to number 1, then we're going to look at question 2, then we're going to do some analysis on question 3, question 4, question 5, etc. That is not the way that we look at data on a survey. All right, remember when we wrote our survey, it was because we started with some objectives, some things that we wanted to learn about the population. In the case of the ADHD survey, this was things like, what kind of student is more likely to be taking ADHD medication? Where are students getting it? What set of side effects, but also effects on their academics are they experiencing as a result of taking these prescriptions? All right, so there were some things that we wanted to learn. And we couldn't just write those questions on the survey, because if you just write on the survey, do students experience an increase in their GPA as a result of taking these medications, you can't write that on a survey, because you would just have a bunch of students guessing about whether or not ADHD medication improves GPA. So what we did is we asked people, how often do you take these medications, and what is your GPA? And then later we're going to look, we're going to answer this question, does taking the medication improve your GPA? Right, and so it's the same thing here. We have these 5 questions. These are survey questions, but now there are some research questions that we can answer based on these questions from the survey. Right, I'm just saying question over and over and over again, and I apologize for that. All right, so first thing that we might be interested in answering, you can imagine this is the data analysis plan. We might want to know, are weekdays and weekend days equally popular for grocery shopping? All right, so if we want to determine what kind of test we are going to do here, I'm going to show you guys 2 ways to get to the answer, because I know that not everyone likes this table. All right, so I'll show you a second way to try to get to the answer here. First way to get to the answer. Look at this question. First thing that you ask yourself, does this question ask me to divide my sample up into groups of people? All right, does it say something like, is one kind of person the same kind, the same as another kind of person in terms of when they go grocery shopping? And the answer here is no, it does not. All right, so this question, are weekdays and weekend days equally popular for grocery shopping, is going to use data from only this one question. All right, and when it's only looking at the data from one question, there can't be a predictor. All right, because there has to be an outcome variable. All right, but there does not have to be a predictor. So if there's only one variable being referenced by a question, that one variable has to be an outcome variable. All right, so in this case, we just have this one outcome that we're interested in. Do people, are they circling weekday or weekend when they answer this one question? All right, so once we've determined that, do I have a predictor or not? In this case, no, we have no predictor. That means we're going to be doing one of these 3 tests because it's in the column of this table where we have no predictor. All right, so we've now narrowed it down from 6 tests to 3 tests. It has to be one of these 3. And the next thing we have to do is figure out which of these 3 tests is it going to be. All right, so we look at the variable, the question on the survey that this data is coming from is this one right here. On which day are you most likely to do your shopping? On a weekday or on a weekend day? People have to circle one of these 2. You ask yourself, is this categorical or continuous data? All right, this is a nominal response scale. People choose one of these 2 categories that they belong to, weekday shoppers or weekend shoppers. And nominal data produces nominal response scales produce categorical data. So we have no predictor and a categorical outcome. So we would do a chi-square goodness of fit. All right, that would be our answer to this question. If this were on the exam, all right, and I told you on the exam, a researcher has asked on a survey, on which day are you most likely to do your shopping? And respondents had 2 options to choose from, weekdays or weekends. And now the researcher wants to know, are weekdays and weekend days equally popular for grocery shopping? What kind of test should he use? You would have multiple choice options and you would circle chi-square goodness of fit. All right, let's say you don't like the table. Fine, you don't need the table. The other way that you can look at this is you can try to break down the logic of what this question is asking. All right, so we are going to have 2 options that people could circle here. Weekday and weekend. And people in our sample are going to provide some answers here. Some proportion of them are going to circle weekday and some proportion are going to circle weekend. And we want to know, is what they circled equal to a distribution that suggests equally popular? So are people circling these 2 options equally, meaning that 50% of our respondents circle weekday and 50% of our respondents circle weekend, or are they choosing some distribution that's different? All right, and when we do this test, that's a chi-square goodness of fit. All right, this is what I observed equal to what I expected. If you look at the hypothesis formats for these different tests, if you want to test the hypotheses, null hypothesis, what I observed is equal to what I expected, versus the alternative, what I observed is not equal to what I expected, then the test that you need to do that is a chi-square goodness of fit test. All right, and so you can back into it that way. All right, but so this kind of question needs a chi-square goodness of fit test. All right, so there's one question that we could ask from answer from this data. I should be doing this on different sheets of paper. Let me thank you for being patient with me. Okay, here's our survey again. Let's say a second question that we're interested in answering is, do men and women shop on the same days? Okay, so we have this one question on our survey. Sorry, let me make sure you can see it. This one question on our survey, what's your gender, male or female? And we have this other question on which day are you most likely to do your shopping, a weekday or a weekend day? All right, and so now we want to know, are men and women tending to shop on the same days? All right, so why might we be interested in this? Maybe, maybe if this is the 1950s, then we think that all of the delicate women are staying home to care for their perfect angel children. And so they are home during the week, and maybe they want an excuse to get out of the house, so they do their grocery shopping on a weekday. Versus men, if men are doing grocery shopping, they have to work during the week, obviously, and so they only have the weekends available for their grocery shopping. So maybe we would expect to see the women tending to circle weekday and the men tending to circle weekend. All right, or maybe everyone shops on the weekend. All right, maybe all the men are working and all the women are working and everyone does their shopping on the weekend. Or maybe you guys have probably not gone grocery shopping with small children, but it's hell on earth. And so maybe the women do not want to go grocery shopping with their children. So on the weekend, they dump the kids on dad and the women go grocery shopping alone on the weekend. I'm not saying that's what I do. I'm just saying that's a thing that could happen. So we want to know, is there a pattern here that suggests that men and women shop at the same time, or that men and women are showing some predictable tendencies where one group is more often choosing one day and another group is more often choosing the other day, right? And so we want to find out, do men and women shop on the same days or are they shopping on different days? If we want to use the table, our first thing that we have to ask ourselves, does this question ask me to divide my sample up into groups, right? And it does. I'm looking at two different types of survey respondents, men and women. All right, so gender is measured with a nominal response scale. All right, here people could just circle male or female. Nominal response scales give us categorical data. All right, so I have a categorical predictor variable. All right, and so now I've narrowed it down from 6 possible options to 2 possible options. All right, it's either going to be a chi-square test of independence that I'm doing or an independent samples t-test. Both of these tests ask, is group 1's answer equal to group 2's answer? They differ, though, in what it is about these groups that we're interested in. All right, and so in this specific question, the thing about what these people are doing that we're interested in is when they're shopping. All right, and when they're shopping is measured on this nominal response scale, weekdays and weekends. All right, and so that is categorical data. So we have a categorical predictor and a categorical outcome, and that gives us a chi-square test of independence. All right, so for this question, we would circle chi-square test of independence, and on the test, chi-square will always be written as chi-square because I cannot figure out how to insert a chi symbol yet. All right, so chi-square test of independence. The other way, all right, if you don't like the table, is you can ask yourself sort of mathematically, what is this asking me to do? I would have the answers from the men and I would have the answers from the women, and some of them would choose weekday and some of them would choose weekend, right? I can't calculate the mean of weekday and weekend. What I have to ask is what percent of men chose weekday and what percent chose weekend, what percent of women chose weekday and what percent of women chose weekend, and then ask, is this, oh guys, I can't undo this video, okay. We put the predictors at the tops of the columns, so I'm sorry. Men and women, weekday, weekend. It doesn't affect the results, but I want to be consistent with what I've shown you previously. So the men are going to answer some proportion weekday and weekend. The women are going to answer some proportion weekday and weekend. And we want to know, is this pattern of responses that we're seeing from the men equal to the pattern of responses that we're seeing for the women? If we look at our hypotheses, we want to know if group 1's distribution of responses, this is a distribution because it's a frequency distribution. How many men circled weekday, how many women circled weekend, right? These are proportions. They are not means, right? We can't calculate a mean of weekday and weekend, right? So we have a distribution. What percent said weekday, what percent said weekend? All right, so is the distribution, the frequency distribution for group 1 equal to the frequency distribution for group 2, or are they different? That's a chi-square test of independence. All right, so when you are deciding what kind of test to do, honestly, I think that doing it this way is probably better in terms of actually learning what's happening with these tests. I give you guys this table because at the end of the day, you just need to be able to find what kind of test to do and then ask SPSS to do it. But in terms of conceptual understanding, I think that writing out what the question is asking you to do probably helps conceptually more. But the table, use the table. By all means, use the table. All right, and either way, we come to this result, the chi-square test of independence. Okay. Next example. Here's our survey. All right, we have all these questions. Let's say that we want to answer the question, do customers enjoy shopping at Kroger? Okay, so we have this question on the survey. How much do you enjoy shopping at Kroger? 1, not at all. 9, very much. 5 is kind of neutral. They don't dislike it or like it. They're just, neutral about it. They don't really care. All right, and so if we want to use the test, or the table rather, we can ask ourselves, does this question ask me to divide my sample into groups? All right, does anything about this question suggest that I'm comparing 2 different kinds of customers? And no, it does not, because we see this phrase, do customers, all the customers. All right, so we're back in this column here where there's no predictor. And then the next thing that we have to find out, we've narrowed it down from 6 to 3. The next thing we have to figure out is which of these 3 is it? All right, and so we have to ask ourselves, what is it about customers that we're interested in? All right, this group of all people, what other question are they answering that now we're going to look at? All right, and so what we're interested in is, how much do they enjoy shopping at Kroger? All right, this is measured on an interval response scale, 1 to 9. All right, so we have this one continuous measure. We're just looking at the data from this one survey question. How much do you enjoy shopping at Kroger? And we want to know their answer. Where is their answer on this one question? All right, so we have one continuous response. That's what this one here means. We have one continuous response. So we're going to do a one-way t-test. All right, the other way that we could figure this out. The question is asking us, do customers enjoy shopping at Kroger? All right, so we have this one continuous measure, so we can calculate the mean enjoyment of shopping at Kroger. Sorry, I wrote that where you can't see. Mean enjoyment of shopping at Kroger. And now we want to know if this mean indicates that they enjoy shopping. All right, so we have to ask ourselves, what would have to be true of this mean to imply that they enjoy shopping? All right, and here, what would have to happen, this thing right here is driving me crazy. What would have to be true is that mean would have to be greater than 5. All right, because if the mean were equal to 5, that would mean they were neutral. All right, they don't enjoy or unenjoy shopping at Kroger. If the mean was less than 5, then they would not like shopping at Kroger. But if the mean is greater than 5, this means that they're saying, to some extent, either a little bit or a lot, they enjoy shopping at Kroger. So what we want to know is, in the sample, what is the relationship of the mean we found in our sample and that midpoint of the scale? Does the mean equal 5, all right, meaning that they don't enjoy it, they're neutral, or is the mean different than 5, all right, meaning hopefully they enjoy it, or for Kroger, hopefully they enjoy it, or possibly they don't enjoy it, all right? So we want to know, is the mean of this variable neutral, or is the mean indicating something else, right, either enjoyment or dislike? And if we want to do a test where we calculate one mean and then compare it against a specific number that has theoretical relevance to us, in this case 5, the midpoint of the scale, then we're going to do a one-way t-test, right? And that one-way t-test is going to ask, is the observed mean equal to that test value, in this case 5, or is the observed mean different from the test value, right? In this case, indicating like or dislike for Kroger. Right, and so since that's what the one-way t-test does, it compares one mean that we've calculated against some specific number that we are theoretically interested in. In this case, it's 5. Then we would do a one-way t-test. All right, another example of a one-way t-test. We have this question, how much do you spend per month on groceries? Let's say we want to know, do people spend more than $500 per month on groceries? All right, again, from the table perspective, we're not dividing up groups of people. This just says do people, all the people. And the thing about the people that we're interested in is how they answered, this ratio response measure. Ratio scale data is continuous. All right, so we would have no predictor, one continuous outcome, all right, how much they spend on groceries. And again, we would do a one-way t-test. Conceptually, we would calculate mean grocery spending, right? GS for grocery spending. And we would want to know, is mean grocery spending equal to 500, right? Or is it equal to some other number? One place where, some students have sent me emails asking, am I interpreting this data analysis correctly? One thing that is just, there's not like a perfect way for me to say, this is why this happens. It's just, this is what happens. Typically, when we ask questions, the way that we naturally ask the question corresponds to the alternative hypothesis. All right, so we don't normally ask questions like, do people spend exactly $500 a month on groceries? Which would be the null hypothesis, that they are spending exactly $500 a month. Our natural way of asking the question tends to correspond to the alternative hypothesis. Are people spending more than 500? Do customers enjoy shopping at Kroger? Where enjoy shopping means that the mean is greater than 5. That's the alternative hypothesis. All right, so keep that in mind when you're looking at questions, when you're trying to do this data analysis interpretation. The wording of the question does not have to correspond to the null hypothesis. All right, you just have to know that if people are spending more than $500 a month, that means that their answer is not 500. And if we want to test to figure out which of these two things is more likely to be true, then we're doing a one-way t-test. Observed mean equals test value, or observed mean does not equal test value. That's what's happening right here. All right, this would be the null and alternative hypotheses for this one-way t-test. All right, so that's a one-way t-test. You calculate the mean of one continuous measure from your survey. All right, in our first example, it was this survey question. You have one continuous measure on your survey, you calculate the mean to that one continuous measure, and then you compare the mean to some number that you pulled, it doesn't matter where the number came from. It's just a number that's theoretically relevant to you. In our cases, it was the midpoint of the scale or $500. I don't know where I pulled 500 from, but let's say like the national average is 500 a month on groceries. And we want to know if the people in our smaller population, maybe Oxford residents, are they spending the same as the national average or some amount that's different? Okay, one-way t-test. Let's see what else we can answer from this. Let's say that we want to know my personal experience. So I'm a Kroger shopper. I don't know why. I just started going to Kroger when I moved here, and I just never stopped going to Kroger. All right, and so one thing I've noticed when I'm at Kroger, especially among the college students, seems to be that I see a lot more female college students at Kroger than I see male college students. And especially when it comes to my own students, I feel like I'm much more likely to run into women that I've had in class before than men that I've had in class before. And so maybe I want to know, what number are we up to now? 4. Do men or women enjoy shopping at Kroger more? All right, so which of these two groups of people enjoy shopping at Kroger more? All right, because I'm going to make this assumption that if they enjoy shopping at Kroger more, then they're going to go to Kroger more. All right, and then I'm going to see them there more often. All right, so this question, let's return to our table. Sorry, get rid of this. Does this question ask me to divide my sample up into groups, right, based on some question from my survey, right? And it does, men and women. That is a measure from my survey. What's your gender, male or female? All right, and so that is a categorical measure, which means we are in this column. All right, we've narrowed it down now from 6 to 2. All right, so we're either going to be doing a chi-square test of independence or an independent samples t-test, and that decision hinges on what it is about the men and the women that we're interested in. And what we're interested in is how much they enjoy shopping at Kroger. So we go to our survey and we see that how much you enjoy shopping at Kroger is measured on this 9-point interval response scale. That is a continuous measure. All right, so we have a categorical predictor, a continuous outcome. We're going to do an independent samples t-test. All right, so we would write independent samples t-test. All right, if you don't like the table, all right, and you want to look conceptually at what's happening here. This is asking, remember we have this survey question, how much do you enjoy grocery shopping at Kroger? And what this question is asking is the mean of that question for the men equal to the mean of that question for the women? All right, so do men and women enjoy shopping at Kroger the same amount, or does one group have a higher mean, so one group enjoys it more than the other? When we have this that we're testing, are these two means the same, the means of these two groups the same, or are those two means different? We look over here at this sheet of paper and we see this is getting pretty small. I don't know if the camera can really focus on this. I don't know, now I've ruined something. Maybe if I turn this light off, that'll be better. All right, so we have mean of group 1 equals mean of group 2, or mean of group 1 does not equal mean of group 2. That is exactly, let me get this paper out. That is exactly what we have written down here. Is the mean of group 1 equal to the mean of group 2, or are those two means different? All right, and so when we need to test that, that is an independent samples t-test. The independent samples part is referring not to having drawn two different samples, but within our sample, we have two independent groups. People have to be in one and only one of these categories. Someone could not have circled both. right? And so once we divide people into two independent groups, just the men and just the women, are the means of those two independent groups the same, or are the means of those two independent groups different, right? And that's an independent samples t-test that answers that for us. Okay, looking back at our survey, another thing that we might be interested in answering is, we have these two questions. How much do you enjoy grocery shopping at Kroger? How much do you enjoy grocery shopping at Walmart? We could answer this question: do people enjoy shopping at Kroger or Walmart more? I'm not sure if that's good grammar, but do people enjoy shopping at Kroger or Walmart more? All right, which one do they like shopping at better? We have assessed how much they enjoy shopping at Kroger. We have assessed how much they enjoy shopping at Walmart. And now we want to know which one do they like better, Kroger or Walmart? All right, if we go to our table, does this question ask us to divide our sample up into groups? No, right? It just says do people, all the people, right? It's not asking us about certain types of people and comparing them to other kinds of people. It's just saying, do people enjoy shopping at Kroger or Walmart more? All right, so we are in this no predictor column. We've narrowed things down from 6 to just 3. It has to be one of these 3. The question now that we have to answer is, what kind of outcome are we looking at? And we are actually looking at 2 outcomes. How much do they enjoy shopping at Kroger? How much do they enjoy shopping at Walmart? Both of these are measured on continuous response scales. So we have 2 continuous outcomes. So we're going to do a paired samples t-test. All right, so the answer to this one is paired samples t-test. All right, if you don't like the table, what this question is asking, do people enjoy shopping at Kroger or Walmart more? If we want to summarize how much they like shopping at Kroger, that would be the mean to that question. How much do you like shopping at Kroger? And then we could summarize how much they like shopping at Walmart by looking at the mean to this question. All right, what is the mean enjoyment of shopping at Walmart? All right, and we can ask, are these 2 means equal? All right, or are these 2 means different? Right, equal means people enjoy shopping at Kroger and Walmart equally. They think the experience is about the same. Or they, down here, they like one of them more than the other. They enjoy shopping at one more than the other. When we do this, all right, shopping at Kroger, that's question 1 on our survey. Shopping at Walmart, that's question 2. If we look at these hypothesis formats, this is getting so blurry. Let's zoom way in here. For the paired samples t-test, we have, is the mean of question 1 equal to the mean of question 2? In this case, is the mean of enjoyment at Kroger equal to the mean of enjoyment at Walmart, or are these 2 means different from each other, right? And that is a paired samples t-test. This paired samples part is referring to the fact that you have a sample of people that have answered a pair of questions, right? And you are looking at the data of this pair of questions when you do the analysis, all right? So you are not dividing into independent samples, you have paired samples. You have 2 columns of data that have answered a pair of questions. All right, and that's what the paired samples t-test does. One thing that I want to point out here, it's not going to be true 100% of the time, but it's not going to be true for distinguishing the paired samples from bivariate correlation 100% of the time. But in order to do a paired samples t-test, these 2 things have to have been measured on the same response scale. All right, so the question here is different. How much do you enjoy Kroger? How much do you enjoy Walmart? But the response scale is exactly the same. 1 to 9, not at all, to very much. All right, so we have the exact same response scale. A 2 here means the same thing as a 2 here. And because of that, we can compare these. All right, we can ask, is the mean on this scale equal to the mean on this scale? Because if it was, that would mean the same thing. All right, a 3 here means the same as a 3 here. With a paired samples t-test, this has to be true. You have to have measurement on the exact same response scale. With correlation, all right, which I assume that you guys can recognize is what's coming next because it's the only test we haven't talked about, that does not have to be the case. It could be the case, all right? We could ask, is there a relationship between how much people like shopping at Kroger and how much people like shopping at Walmart? And for that, I would recommend going to the YouTube channel and looking at the video that's called Difference Between Paired Samples T-Test and Correlation, because it goes into that in more detail. But a correlation will allow us to look at a relationship
between two continuous measures that are measured on different response scales. All right, so for example, we could ask, is there a relationship between how much you spend on groceries that should be and, not at, and how much you enjoy shopping at Kroger. All right, so one thing that I have learned, I don't know if this is true, like I don't have data to suggest that this is true, but one thing that I've learned is that there's a perception that it's more expensive to shop at Kroger than at Walmart, or that, which strikes me as funny, that Kroger is like the uppity grocery store and Walmart is the less uppity grocery store. So maybe there's a relationship where people who spend more money on groceries like shopping at Kroger more, and the people who are, you know, looking to spend less on their groceries don't like Kroger as much because they perceive it as being more expensive. All right, and so with this question, it's a little tricky to say, do I have a predictor here? What's the predictor? Because technically the predictor is how much you spend on groceries. All right, but I recognize that it's kind of hard to see that in this question. So instead, what you can do is, if you see this word relationship, the word relationship tells you there has to be a predictor, because you can't have a relationship between nothing and an outcome variable, all right, suggesting that there would be no predictor. If there's a relationship, you have to have a predictor variable. So this word relationship in a sentence is telling you, you have a predictor, it's either categorical or continuous, and you're going to do one of these three tests. All right, so here, this word relationship is a trigger for us. It tells us, yes, I have a predictor variable. If I look at this first variable that shows up here, which is, you know, it doesn't really matter, you could look at either of them. We have how much you spend on groceries, continuous response scale. How much you enjoy shopping at Kroger, continuous response scale. Either one of those can be the predictor. It doesn't matter, because when we have a continuous predictor, the only test that we have available to us is a bivariate correlation. All right, and what the bivariate correlation, well, first let me just write. Our answer here would be correlation. I'm not going to write bivariate on the test because it just takes longer for me to type, to be perfectly honest. What this correlation is doing is it's asking, if you don't like the table, as you spend more money on groceries, all right, so as your grocery bill increases, I'm going to put this back and forth because I don't want to confuse people and make you think this is a causal relationship, but is there a pattern between how much people spend on their groceries and how much they enjoy Kroger? All right, and this pattern could be that as they spend more money on groceries, they also tend to like Kroger more, or it could be that as they spend more on groceries, they tend to enjoy Kroger less, or there could be no pattern. All right, so I don't know how to write no pattern, but it could be that the amount of money that you spend on groceries has absolutely no relationship with how much you enjoy Kroger. There is no pattern here. You could not use this information to predict this information, and in this case, there would be no correlation. All right, and so this test that asks, is there a relationship between one continuous variable and a second continuous variable, is correlation. The null hypothesis here is always that there is no correlation, that the correlation coefficient R is equal to 0, and the alternative is if there is a correlation, all right, and that means that R is not equal to 0 in the population. All right, so these two, I know people get mixed up because in both cases you have two continuous measures. With a paired samples t-test, you have no continuous measures, or two continuous measures and no predictor. With a bivariate correlation, you have two continuous measures because one is a predictor and one is an outcome variable. There is already a video on YouTube that talks a little bit more in depth about the difference between paired samples t-test and correlation. So if you are having difficulty distinguishing between those two, I would refer you to that video, all right, instead of making this video even longer than it already is. All right, so there's all the different kinds of tests that we talked about in the table. All right, and remember that on the exam, there are going to be 16 questions that ask you to pick the test. All right, it's going to be like this. I don't think, you know, if this was a paper test that I was handing out in class, it would look exactly like this. I would say, you know, imagine here's a survey that had these questions, and now the researcher wants to know, do men and women shop on the same days? What kind of test would he need? on the exam, because of Blackboard, I don't think that I can give you, like a bunch of information and then ask you questions based on that information. So I think it's going to be in individual questions, like a survey question might say, imagine a researcher has asked on a survey, are you male or female? And do you tend to shop on weekdays or weekends? All right, and now the researcher wants to know, do men and women shop on the same days? What kind of test does he need? And then you would circle chi-square test of independence. All right, so the questions are going to be a little longer because I have to give you that, how the things were measured, so that you know, is it categorical or continuous in the question itself. But it's going to be this exact format. It will not be about ADHD medication, so it's not going to be questions from your data analysis plan. But I would suggest, if you are feeling like you don't really have this down, I would recommend going to Blackboard, printing a clean copy of the data analysis plan. I'll make sure that one of those is posted. I'm not sure if it is. It might have disappeared once the assignment had to be turned in. But I'll make sure that a clean copy of the data analysis plan is there. When I say clean copy, I mean one with no answers on it. So you could print that off, try to go through all 50 questions again and answer them. And now the answer key is posted to Blackboard. So once you go through and answer them, you could grade yourself. All right, and the grading yourself, I think, is valuable for two reasons. One, you can find out overall, do I seem to have this? But two, if you find that you are missing the same test every time, it's just one-way t-test, you just missed that one every single time, then that tells you go back and read more about one-way t-tests. All right, watch one of the supplementary YouTube videos that I posted where if you don't like how I'm explaining it, I'm sorry, I apologize for that, but I posted some other videos where you can look at how other people explain one-way t-tests, and maybe that works better for you. All right, but that is, if I were studying for this test, that is something that I would do. I would print off the data analysis plan and do it again. Especially, I hesitate to say this, but I'm not going to accuse any specific person. The grading and the distribution of missed questions suggests that some groups may have benefited from information from other groups when they turned in the assignment, which was not explicitly prohibited. So I'm not going to, grade against them. But it does suggest to me that they did not get any practice doing this. All right, and so for those people, that's roughly 20 or 25 points on the test that they are potentially going to miss if they don't learn how to do that before the final exam. All right, normally in class, this is where things would end. The kinds of questions that I normally have to answer don't apply here. You don't need a Scantron. Obviously you can have a calculator, but you will also have, computers and cell phones and books available to you, so we don't have to worry about that. Several students have asked me, do you need to know anything about SPSS for the test? No. Right? In a typical semester, I would not explicitly ask any questions about SPSS, but normally on the final exam, I would just give you screenshots of SPSS printouts for this interpreting the results of a data analysis question. But because you guys, because we didn't do that, we couldn't do that because of stupid coronavirus, on these 4 questions, it will say something like, here, let me give you an example of what that might look like since I didn't already. Let's look at this, this question, do men or women enjoy shopping at Kroger more? The question on the test would say something like, a researcher, sorry, I should have written this before I came here. A researcher wanted to know if men or women enjoy, sorry, I looked at the screen again, shopping at Kroger more. So he collected survey data where respondents indicated their gender, and evaluated shopping enjoyment on a 9-point scale anchored 1 equals not at all and 9 equals very much. All right, so I would tell you, here's how these things were measured on the survey. Here's what that survey, you know, if it was an interval response scale, here's what the low numbers and the high numbers meant so that you could interpret the data. And I would say the results of his independent samples t-test are below. And then underneath this, it would say, you know, X bar men equals 7.2, X bar women equals 8.4, T equals, you know, some number, P equals some number. I would give you these numbers, right? And then you would have to interpret what these numbers mean, right? And so there would be some blank lines for you to write your result. And when you write the result would need to be written in the format that you would write it in the results section of your paper. All right, so it needs to be that conclusion in plain English. All right, and so, you know, here I would write, because P is less than 0.05, my null would have been that men and women are equal. My alternative would have been that men and women are different. Because P is less than 0.05, I would reject the null and side with the alternative. And I would conclude that women enjoy shopping at Kroger more than the men do. And the evidence that supports that is that the mean for the men is equal to 7.2 versus the mean for the women equals 8.4. And my T statistic was 4.24, and my p-value was less than 0.05. All right, and so if you wrote this on the test, you would get 5 points, or 4 points, however much it's worth. Sorry, 4 points. 4 questions like that worth 4 points each. All right, so this is what those last 4 questions are going to look like. All right, something like this. This is what you should prepare yourself for. It is basically exactly what you're doing as you write the results section of your final paper. All right, so on the test, if we look at these different sections of the test, I am assessing your general knowledge about the topics that we've covered since the midterm in 40 questions. Then I'm assessing your ability to determine what type of analysis needs to be done, right, given a research question and the data you've collected, right, which is what the data analysis plan also did, right, but the data analysis plan does not evaluate that individually, all right. I assume in a lot of cases that one group member was doing more than their fair share of this assignment. And then these last 4 questions are assessing your ability to interpret the results of an inferential statistical test, right? And that's what the results section of the final paper is assessing. But again, if one person does all the work in the results section, then I don't know individually how well you guys have picked that up, right? And so I measure it again on the final exam. All right, so I have no idea how long I've been talking. I suspect that this has turned into a really long video, but I hope that it has been helpful. Again, here's the basics about the test. You're going to have 90 minutes to complete it, beginning at noon on either Tuesday or Thursday, depending on which section of the course you're in. Someone told me today that there's like passwords or something. I'm not going to do that. The test is just going to open at noon for students in one section of the class. All right, and it will close at 1:30. All right, and so between noon and 1:30, you need to take that whole test. And it will cover these topics, which correspond to these topics in the textbook. And I would recommend that you look at these materials to study for the test. To preempt, so 2 things that I want to point out here in the video if you're still listening. Number 1, the first exam is on Tuesday. The paper will be turned in on Sunday at midnight. I can guarantee you that the papers will not be graded before you sit for that final exam at noon. All right, so unfortunately, you will not know what your grade is prior to taking the test. However, from my perspective, that's good, because oftentimes I see students doing these calculations like, well, I only have to get a 60 on the test to keep my B in the class. And the problem with that is that they don't study enough and then they undershoot and they don't get a 60. All right, so I want everyone to say, I need 100 on this test and study as though you need 100 on the test. All right, but do not expect to have the grades on your final papers before you take the final exam. The second thing that I want to point out, we talked about it on the first day of class, it's written into the syllabus. Once your exam day rolls around, all right, and noon happens on that day that your section takes the exam, I will no longer answer emails about grades in the course. All right, so if you have a question about your grade in the course, you need to ask it before your final exam date. All right, once you take the final exam, nothing about your grades can possibly change. All right, I'm just going to grade your exam based on whether or not you answered these 60 questions correctly, and that grade will go into the grade book, and that's it. All right, there's, you know, the extra credit has been assigned and completed and graded. There is no opportunity for any additional extra credit in this course. All of the assignments will have been turned in by the time that rolls around. All right, and so I just am not going to, you can send me an email and I will read it, but I'm not going to reply to it. All right, and of course we can't have any office hours because we can't be within 6 feet of each other. All right, so I'm not saying that to be mean, it's just the end of the semester. Sometimes awkward things happen at the end of the semester around grades, and I would like to prevent that for all of us. Because I won't see you on the final exam, I'm sorry that things turned out this way. I feel like I missed something because normally it's the second half of the semester where I get to know all of you guys as I, you know, come around to work with your groups on completing your data analyses, and I didn't get any of that. All right, and so I miss seeing you guys in here. This is a weird semester. For those of you who are graduating, congratulations. I'm sorry that it won't be a physical ceremony here in the Grove next weekend. The weather was even going to be nice, which never happens. Those of you, one of you, I think, is a junior in this class that's not graduating. I hope that in the fall we're here in person on campus. But if you are graduating, I hope that you do big things in life. I hope that you're safe at home, all right, and relatively happy as you can be given the situation. Mostly safe. I hope that you're safe. If you need letters of recommendation, if you need advice on grad schools, on applying for jobs, on search terms for looking for jobs, all right, if you want to hear more about why I think Chipotle is better than Moe's, please send me an email or stop by my office once office is open again. But I hope you have good lives from here on out, and good luck on the test, all your tests. I hope finals week goes well for you. See you guys later for the last time. I feel bad about it.